Okay, in this recording, I'm going to be reviewing for the Precalculus midterm. So the very first problem on the calculator section tells us to solve 2 to the 3x plus 1 is equal to 375. Then when we see an exponential equation like this, we solve it by using the inverse, which is log. So we'd go ahead and take the log on both sides. Then we could go ahead and bring the power down, so 3x plus 1 is equal to the log of 2, or 3x plus 1 is in front of the log of 2, and that's equal to the log of 375. If we divide both sides by log 2, we get 3x plus 1 is equal to the log of 375 divided by the log of 2. And I'm getting that this is 8.5507. Subtracting 1 gives us 3x is equal to 7.5507. And then dividing by 3 it gives us x is equal to 2.5169. The second problem, it gives us a bacterial population. So the bacteria population is modeled by B of t is equal to 2500 times e to the 0.15 t power. First question is going to ask you what the initial population is. The way you do the initial population is you set t equal to 0. And if t is equal to 0, we get b sub t of 0 is equal to 2500 times e to the 0.15 times 0 power, which is just 2500. E to the 0, or 2500. We know anything to the 0 power is 1, which gives us this. Second question will be how long until the population doubles. So if the initial population is 2500, when we double that, we multiply it by 2, and we're trying to go ahead and solve for t now. So 2500 e to the 0.15 t power. And in order to solve this, we're going to divide by 2500 on both sides. And we just get 2 is equal to e to the 0.15 t power. Take the natural log of both sides. And in our calculator, we're just going to have to do the natural log of 2 divided by 0.15. And let's see what that is. The natural log of 2 divided by 0.15 is 4.6210. Okay. Moving along to the non-calculator section. First problem is going to be a rational inequality. So we have a problem where it's x minus 3 divided by 2x squared minus x minus 3 is greater than or equal to 0. When we talked about solving problems like this, what we're going to do is first solve it like an equation. So x minus 3 over 2x squared minus x minus 3 is equal to 0 over 1. solve by cross multiplying, and we get x minus 3 is equal to 0, and then x would just equal 3. We could also go ahead and figure out when the denominator is 0 by factoring. So factors of -6 that add up to -1 are -3 and 2. So we'll do 2x squared minus 3x plus 2x minus 3 is 0. Take out an x, we're left with 2x minus 3. Take out 1, we're left with 2x minus 3. So we get x plus 1 times 2x minus 3, which gives us x is -1 and x is 3/2. The next step is we have to test values on a number line. So if we test values before -1, between -1 and 3/2, between 3/2 and 3, and then numbers greater than 3, this will give us a better idea of what regions are going to work. So this is something we're just going to have to do in our head. So numbers less than 1, I'm going to pick -2. Between -1 and 3/2, I'm going to use 0. Between 3/2 and 3, I'm going to pick 2. And bigger than 3, I'll pick 4. And what we're going to do is plug those into our inequality. If you plug in -2, I'm getting -5 over 4 times 2 is 8, 8 plus 2 is 10, 10 minus 3 is 7. And that is not greater than 0. If you plug in 0, I'm getting 1, which is greater than 0. If you plug in 2, I'm getting -1 over 8 minus 2 is 6 minus 3 is 3. This is not greater than or equal to 0. And then if we plug in 4, we get 1 over 16 times 2 is 32 minus 4 is 28. 28 minus 3 is 25, and this is greater than or equal to 0. So the way that we finish this is we just have to test the boundaries. And if we do that, we know that we can't use -1 and 3/2 because those would make our denominator 0. But if we were to plug in 3, we'd get 0 is greater than or equal to 0, which is true. So the way that we would write this in interval notation is we'd say from -1 to 3/2 in union with 3 to infinity. Next problem is a circle problem. So we want to figure out the center and radius of x squared plus y squared minus 10y minus 39 is equal to 0. And let's go ahead and group the x's together. We'll group the y's together. And we'll just bring this 39 on the other side. So the x is already a perfect square, but we could factor out a 1 here. Take half of -10 and then square it, that's 25. And then multiply that by 1 and subtract it. So we get x squared plus y minus 5 squared is equal to 25 and 39 is 64. And then it looks like our center would be 0, 5, and the radius would be 8 units. Okay, moving to the next problem. Let's look at the parent graph of y is equal to the cubed root of x, we know the parent graph generally looks like this. It looks like it goes from left to right. So what I'm going to do is I'm going to make a few changes, and I'm going to ask you exactly what's happening here. So let's make 5 changes. Okay, and what I'm going to do is I'm going to pick one option where I put a +2 on the outside. What you're going to do is you're just going to tell me that this graph goes up 2. If I put a negative in front of the graph, you're going to tell me that this reflects over the x-axis. If I put a -3 on the inside, you're going to tell me that this goes to the right 3. Remember, inside tells you whether you go left or right, depending on if it's positive or negative. Outside tells you whether it goes up or down, depending on if it's positive or negative. Let's do a couple more. What if I asked you to do the cubed root of x plus 1 minus 2? You're going to tell me that this graph goes to the left 1 and then down 2. And then finally, if I gave you the cubed root of x plus 5 with a negative in front, this graph is going to reflect over the x-axis, and it's also going to go left 5. So you just have to tell me in words what's going on there. For problem number 4, we're going to determine if even, odd, or neither. All right, and I'll give you a couple of graphs here. So let's take a look at a problem like this. Say we had f of x is equal to 3x over x squared minus 1. And let's take a look at if we had f of x is equal to x squared over 4. The way we determine if they're even, odd, or neither is we plug in the opposite of x, and if it comes out to be the same thing, then we know that it's even. If we plug in the opposite of x and we get the opposite, then we know it's odd, and if neither of those happen, then we would say that it's neither. For this first graph, if we were to plug in the opposite of x, you'd get negative 3x over x squared minus 1. Well, that looks like the opposite of the original, right? Because this is the original right here. But because there's a negative in front, right? When you plug in negative x, 3 times negative x is negative 3x. We would say that this is therefore odd. For a function like the one on the right, if you were to plug in negative x to the second is x squared over 4. It actually winds up being the same thing. So you would say that this is an even function. Okay, the next problem is a difference quotient. I'm going to ask you to find the difference quotient. Okay. And the problem is going to look like this. If f of x is equal to negative 3x squared plus x minus 4. So remember, for the difference quotient, we have to do 3 things. First thing is we plug in x plus h for all the x's. Then we subtract f of x, and we divide by h. So we're going to have to do these 3 different pieces. First thing is, let's plug in x plus h for all the x's. Next, we're going to subtract f of x. remembering our parentheses, so we subtract the whole thing. And then we're going to divide the whole thing by h. So we just have to make sure we're careful. For this piece, you want to make sure you distribute x plus h times itself. And you'd get negative 3 times x squared plus 2xh plus h squared plus x plus h minus 4 plus 3x squared minus x plus 4. Okay, and finishing this up, we distributed everything out on top, so now what we're going to have to do is combine like terms. And divide by h. So we get negative 3x squared minus 6xh minus 3h squared plus x plus h minus 4 plus 3x squared minus x plus 4, all divided by h. So let's go ahead and cancel out our terms. And this negative 3x squared cancels here. This x cancels here. This negative 4 and this 4 cancel. And we're just left with negative 6xh minus 3h squared plus h, all divided by h. And we'll divide each term by h. So this is negative 6x minus 3h plus 1. Next, problem number 6 is it's giving us two functions where we know f of x is equal to 3x plus 4 and g of x is equal to 2x squared minus 3. And the question's asking us to find f of g. So we're going to find this, and then we're going to do the reciprocal too, or the inverse, just so you have an idea of how both work. So for this first one, this means f of g of x like this, and this means g of f of x. So what we're going to do is replace what's inside the parentheses with the actual function. So for this first one, g of x was 2x squared minus 3. And we're going to plug this in for the x in f of x. So this is just 3 times 2x squared minus 3 plus 4. And then distributing, we get 6x squared minus 9 plus 4 is 6x squared minus 5 would be the answer. Now if they were switched and we wanted to find g of f of x would be 3x plus 4, and we're going to plug that in for the x in g of x. So we're going to do 2 times 3x plus 4 squared minus 3. So we'll have to go ahead and distribute this by multiplying it by itself. This would give us 9x squared plus 12x is 24x plus 16 minus 3, or 18x squared plus 48x plus 32 minus 3, or our final answer of 18x squared plus 48x plus 29. That's what that would be. Alright, moving on. Problem number 7, we want to find the roots. And we're going to want to use the location principle for this problem. So let's go ahead and find the roots of, let's say, f of x is equal to 2x to the fourth minus 5x to the third plus 3x plus 1. And when we're doing this, first step we usually do is we find how many positive roots we're expecting, and we just count the number of sign changes. So it looks like there's going to be 2 or 0. For the negative roots, we change the signs of the odd powers of x. So we have a positive, positive, negative, positive. So this is also 2 or 0. Remember, we change the signs of the odd powers of x. And then when we go ahead and do this, just keep in mind that with any kind of division, we have to replace, if we're missing a term, we have to replace it with 0. So I'll do the positive x roots first. So I'm going to do 2, negative 5, 0, 3, and 1. And let's just go out 5 here until we hit an upper bound. So remember, this is just synthetic division. So 2 times 1 is 2, and this is negative 3. And it looks like nothing's going on at 1. We'll do the same thing with 2. This is 4 plus negative 5 is negative 1. This would be negative 2, negative 4, so this is negative 1 and 2. So this is negative 1, and it looks like we have a root right here. Bring the 2 down. 6 and negative 5 is 1. This would be 3. 9 and 3 is 12. 36 and 1 is 37. So we have another root, and we also hit an upper bound when x is equal to 3. So we have roots between x equals 1 and 2, and between x is equal to 2 and 3. Now let's go ahead and find the negative roots. Remember, we're going to change the signs of the odd powers of x, and we're also going to plug in 0 anytime we're missing a term. So we're going to have 2, positive 5, 0, negative 3, and 1. And we're going to go ahead and list this out to 5. So this would be 2, 5, 0, negative 3, and 1. Bring the 2 down. 2 times 1 is 2, and 5 is 7. This would be 7, and negative 3 is 4. 4 and 1 is 4, and 5. So it looks like we hit a lower bound here when x is negative 1. And there are no negative roots because we hit a lower bound without coming across any roots. And remember, the roots are where the last number or the remainder changes sign. Moving on to number 8, we have the function f of x is equal to x plus 3 over x squared minus 9. And the question's asking us to find the domain, the asymptotes, the intercepts, and then we're also going to graph it. Okay. So first thing, the way that we graph rational functions is we try to factor, and actually this problem does factor, and I didn't want it to, so let's just change this to a 2 here. Because if we factor and factors cancel, we get wholes, but that's not relevant for the midterm. So after that, we find the vertical asymptotes by setting the denominator equal to 0 and solving. So this would be x plus 3, x minus 3. And we have 2 vertical asymptotes at 3 and negative 3. So I'm going to go ahead and get this set up. This is when x is equal to 3 and x is equal to negative 3. Next is the horizontal asymptote. Because the top power is 1 and the bottom power is 2, the top is smaller than the bottom, which means y is equal to 0. And then if we go to figure out our intercepts, the y-intercept we get by making x equal to 0. And if we do that, we get y is equal to negative 2/9, which may be over here somewhere. The way we get the x-intercept by making y equal to 0 is we'd get x is equal to negative 2. If you just make y 0 and cross multiply, so we're doing x plus 2 over x squared minus 9 is equal to 0 over 1. So that's where x is negative 2 comes from. Just x plus 2 is equal to 0. So we have the y-intercept, we have the x-intercept. For our domain, it looks like we just can't use negative 3 or 3. So the way we write that is from negative infinity to negative 3. From negative 3 to 3, and then from 3 to infinity. And now we just have to figure out what's actually going on with the graph. So I'm going to test values 1 to the left, so negative 4, and 1 to the right, negative 2. Similarly over here, I'll test 2 and I'll test 4. And if we go to plug those in to get branches, if you were to plug in negative 4, I'm getting negative 2 over 7, which is negative, so your branch is down here. If you were to plug in 4, I'm getting 6 over 7, which is positive, so your branch is up here. And in the middle, if you plug in 2, I'm getting 4 over negative 5, which is negative. So we have a value down here, and if you plug in negative 2, I'm getting 0. So it kind of looks like the graph is doing a cubic. But just to make sure, let's test negative 2.5. If you plug in negative 2.5, you'd get negative 0.5 on top. And if you plug in negative 2.5 on the bottom, you'd also get a negative number. So this would be a positive value, and you do get a cubic looking graph. For number 9, we're going to evaluate logs. And let's say we had log base 2 of 8, log base 5 of the cubed root of 5, 3 times the natural log of e, and then let's do the log of 1. Well, you know log of 1 is 0, natural log and e cancel. We could use inverse properties on these first two. So this is the same thing as log base 2 of 2 to the third, which is 3. And this one is the log base 5 of 5 to the 1/3. So we just have 1/3 here. For problem number 10, we want to expand log base 3 of the square root of 4x to the second divided by y to the 8th. When you're doing a problem like this, remember logs don't like radicals. So let's go ahead and get rid of that radical by writing it as a power. Log base 3 of 4x squared divided by y to the 8th to the 1/2 power. Then we could bring that power down 1/2 times the log base 3 of 4x squared minus the log base 3 of y to the 8th. This turns into a product property, so this is just log base 3 of 4 plus the log base 3 of x squared minus 8 times the log base 3 of y. And then we could bring this down too and get 1/2 times the log base 3 of 4 plus 2 times the log base 3 of x minus 8 times the log base 3 of y. That's how we would simplify something like that. We have a couple more to go. Problem number 11, we're going to be solving a log equation. So just remember your product and your quotient properties. Say we had a problem like this where it's the log of x plus 12 minus the log of x is equal to the log of x plus 5. We could go ahead and use our quotient property. So this would just be log of x plus 12 over x is equal to log of x plus 5. Cancel out our logs using the property of equality. X plus 12 over x is equal to x plus 5 over 1. Cross multiplying would give us x squared plus 5x is equal to x plus 12. And then getting everything on the same side, x squared plus 4x minus 12 is 0. So let's go ahead and factor with x plus 6 and x minus 2. So it looks like our answer could be -6 or 2. The only problem is -6 gives us a negative log, so that's not going to work. The only answer would be 2 here. I wanted to do one more property using the product property. So let's say we had log base 3 of x plus 1 plus the log base 3 of x plus 3 is equal to 1. Well, we could go ahead and use the product property. So this is x plus 1 times x plus 3 is equal to 1. Using the translation property, we'd have 3 to the first is equal to this. Bring the 3 over. So we have an equation where it's equal to 0. Go ahead and factor out the x. And we'd get x is 0 and x is -4. We know that we can't use -4 because that would make the inside of a log negative, so x would just be equal to 0. And then the final property, or the final problem, says we have an equation where f of x is equal to the cubed root of x minus 1. And we want to go ahead and find the inverse. So the way that we get the inverse is we say y is equal to the cubed root of x minus 1. Switch x and y. Solve for y, so let's add 1 to both sides. And raise both sides to the third power. And then say that that's the inverse. Final thing you'll be asked to do is just to graph the two of them on the same coordinate plane. We know the cubed root takes on this parent graph. So the -1 is going to move that graph down 1. So the graph of the inverse is going to look something like this. Or actually, that's the graph of the original. So the graph of the original would just look like that. And then the graph of the inverse, we know that x to the third looks like a cubic like this. We're going to move that graph to the left one. And that graph would look something like this. We'll just go ahead and label. And that is your midterm review.